This is question 2 of the model selection chapter of the regression models book. There aren't a lot of exercises in this chapter. Hopefully going through one model selection exercise will give you a sense of at least how I like to do these things. The first question refers to the seatbelts data set that we've been working on. So go through some of the old problems to refer back to the loading of the data and fitting of the model. But it basically says to perform a model selection exercise and arrive at a final model. And again, I think something we emphasized in the class is that there's many different model selection strategies, and you just want to be sure and clear about what your strategy is. In this case, I think what I'm interested in this data set is whether or not the law was effective. Okay, so I'm going to fit 4 models. The first one is just going to include the law variable. The second one is going to include the law plus kilometers. The third one is going to include the law plus the petrol price. And the fourth one is going to include the law plus petrol price plus kilometers. I'm interested to see what happens. If I do ANOVA, my models aren't nested. So it so you can't look at all of these tests because they refer to the immediately prior one without some calibration. So what we are looking at is the amount of residual sums of squares that changes. And if we did want to compare a model with another model, not in this particular order, for example, we wanted to compare model 1 with model 4, the difference in the residual sums of squares is this number over here. So this 1,009,754 minus that gives you that, which is what then is used to produce the F statistics. So they produce it this way. They give you these just so in case you don't want to compare them in this order. So I'm particularly interested, I think, with the fit 0, and fit 3, because I'm interested in whether or not both those parameters are necessary in addition to the law variable. So here we have our base model, which just has the law variable. Here we have our second model, which includes kilometers and petrol price. So it's a two degree of freedom test because it added 2 parameters. Okay, and the test is highly significant, suggesting that we probably should include both those parameters. The other thing I'm interested in is how my coefficients change depending on what variables I put in. So just to go through this, summary is of course the summary of our fitted model. $coef grabs the coefficient table. If we look at the coefficient table, so let's grab the law row from each one of these fitted models. So summary of the fit, grab the coefficient table, and grab the second row. And I'm going to R-bind them together so I can look at them all at once. So this is the model which I labeled fit 0, 1, 2, 3, 4 in order 1, 2, 3, 4 by rows. So we can see what happens to the law estimate, right? So the law estimate estimates that after the law went into effect, we get an expected 25 fewer deaths per month. However, if we adjust for the variability in just kilometers, that drops down to 17 fewer deaths. If we adjust for just the variability in petrol price, that estimate drops down to 16 deaths fewer per month. And then if we adjust for both, it goes down to 11 fewer deaths per month. We can see that our t-value drops from -4, which is a very large t-value, to -1.97, which is kind of a marginal t-value. And in fact, our p-value goes from highly significant to just barely significant, 0.499, if we're comparing it to a type 1 error rate of 5%. I think in this case, because of the significance of including both coefficients, and because it seems reasonable that in evaluating the law that we want to include the variability associated with these other highly significant predictors, I would likely go with model 4 in this case. But the key, like all these exercises, is to be able to justify your logic and reasoning in picking the final model that you arrived at.